Hello friends, welcome to my channel Code Destination, and we are continuing this challenge one code one day, and we are picking the topic binary search algorithm. So in yesterday class, if you remember, I discussed this question, problem number 33, search in rotated sorted array. So let me just go through the logic what I explained already for some time, so that you can connect the today logic. So yesterday we define we detail we discuss in the detail that how we can search any element, like any target element here, like target element in our given rotated sorted array. So for that we just find our breaking point here, this point. Then from the backing point we just divide it into two half, first half and second half, and we separately search using the simple binary search. And as I said in the previous class, we will solve this question using one binary search, because in this case we solve in the three binary search. So it is total 3 into log n operation, big O of 3 into log n operation. But we will solve if you solve in the one binary search, then it will be only the log n, so it will be more good and more precise solutions. But for that, how we can build that, for that the previous yesterday class is very important, because in that class we did some observation, all the element in the first part. For the first part, if I say, for the first part, all the element is greater than a of 0. This is the first observation which say that we are in the first part. And for the second part, as I already said, all the element is less than a of 0, and a of 0 is nothing but our boundary line. This a of 0 is here, so like a of all the element above that is greater, and all the element below that is less than. So we decided this observation, and the this is the first observation what we get in the previous class. And the second observation we did, for defining the peak element, what is the behavior, a of m is greater than a of m plus 1. So these are some key points which we have to take care about this question. And so same logic we will think, and we will apply in the same in one binary, using one binary search. So how we can do that, in a nutshell, we can see that first we'll define I and jth value, like we did in every binary search first. So we will define here I value and j value, which will define our boundary. So after that we will generally calculate the middle point using I plus j by 2 or I plus j minus I by 2. So there are several cases. Suppose my middle is here, first case, either my middle can be present here or here. So for getting whether my middle point is present in this part or in this part, we have already condition, like if this condition fulfill, like if a of middle value is greater than a of 0, then we can say that it is in the first part. And if it is a of m value, like for middle value, if it is less than a of 0, it means it is the left part. And according to that, once we got that our element is in the our middle point is the first part, and after that we will see our target, whether our target is in this part or not. Suppose my target is here, in this case suppose my target is here. So in that case, what we have to do, suppose my middle point is here, and I just justify that it is in the first part. So we are sure we are in the first part, and I say that my target value is here. So what we have to do, we will just apply the simple binary search. Like if my target is here and my middle point is here, it means my middle value is greater than target. So all the part, after that, all this part we can ignore. So we will just shift my j pointer, which is here, to here. So now my search space is here, I to j. because we justify that we are in the first part and our target value is less than middle value and greater than 0 value. So it means we are in this range, so we can just ignore all this part. Basically all this part we can ignore, because we can show that our target is here. In the same manner, if my target is suppose here, at this point my target is present and my middle point is somewhere here, and we justify that we are already in this third, like second part, by using this condition. So we can see, like, suppose my target is here somewhere present here, and I am with the middle pointer, I am here. So if my middle pointer value is less than the target, it means we can ignore all the part, like all from here to here we can ignore. So that's why we will set my I pointer to after that middle pointer. In that case my search space will start I here, like somewhere here to here. So we'll search only this part. So we'll apply this logic in the same like binary search, so that we can search in the same loop. Okay, let me write it. So for binary search, generally we define the boundary. So once we implement the logic in code, so that you can also connect with the logic what we explain in the theory here, and I will connect with that as well, so that I can maybe clean this little more so that I can connect. So quickly I can write here, suppose this 4 to this one, and here it break. Okay, so from here to here this one, and here that is the point where it is starting. So it is a of 0 value, it is the a of middle value, like top value, and it is the first part and second part. So we can apply the logic, and we'll discuss how we can write the logic in the code. So I define my boundary, and like we did in binary search, my loop will run till I equal to j. Then for every case I will find middle point I plus j minus I by 2. Okay, I got my middle. So for this middle there, first I will check if my middle, like nums of any middle value is target, like we got my target. So sudden, like directly I can return here my mid index because I got. But if it is not equal to target, so it means it can be present either in first half, like either it can present in this half or in this half. Okay, so in that case what we have to do, I will check whether it is present in the first half or second half. So what the condition to check whether it is present in the first half or second half? As I said, it should be, if it is above the boundary, then it is the first half, and it is below the boundary, then it is the second half. So if my nums of like middle value is greater than boundary value, so it means we are in the first half. So we are sure we are in the first half. We can be in the first half, or in the else we can be in the second half. So suppose I am present in the first half, so now I am here, like there are two possibility, either I can be in the first part or second part. So for now I am assuming I am in this part. Okay, so what we can do, like suppose my middle is here, and I am getting that my target is somewhere here, I am searching. Okay, and my middle pointer is here. So I will check whether my middle pointer, like my target value, this is my target. If my target value lie here, okay, in this range, it means my target is greater than a of 0, and my target, and because this both conditions should be fulfilled if my target is less than a of middle value. Okay, it means we are in, like my target is present here, this in this part. So in that case my jth pointer is here now. So like we are sure that our target is present in this range, so we, for all this range, we can just ignore. So my j pointer will shift from here to where, here, because we are shifting the left side, so my j will shift here. And now I will search only this range I to j. Okay, so I will check that one condition. So if my nums of 0 value, like my target is greater than and equal to, and uh, target is less than nums of mid. It means we are in the left part. So what I have to do, I will just move my range, like my right boundary to the mid minus 1. Okay, just before that. And if it is else, so I will just shift my I boundary to m plus 1. When else will happen, let me show you. Like if it is not in this range, suppose that condition is not fulfilled, it means we are not in this range, we are in the like in the this range, we are in this, like my middle value, suppose my target is here somewhere. In that case, that condition will not fulfill, then in that case we will here. So in that case my j will be as it is. Okay, my I will shift from here to here, because now this, like this is we are sure that in this part my target is not present, so my target is present only in this part. And we already checked this, we are in the first part, so I will check only this boundary. I am not considering from here to here, because we are in first condition, we are already sure that we are in the first part, so my like boundary is here, so we will search only this part. Okay, so in the else condition I will just set my I pointer. Okay, and vice versa, if I am in the second part, suppose, yeah, so in the second part, suppose no, I am in this part now, and my middle pointer is somewhere here. Okay, and my target is suppose here, so I will, yeah, suppose my target can be here and here. So suppose I assume my target is in this case here. So in that case, what is the condition? If my target is greater than nums of like a middle value, and if my target is less than, because this is the like, top value, and if it is less than, it means we are in this range. And if it is like nums of last value and minus 1, so it means and so if both condition fulfill, it means we are in this range. So what we have to do, my j pointer will be as it is, I will just shift my I pointer to after that. So in that case my I will be here and j will be here, and we will check only this boundary. Okay, so in the else condition, what we have to do, if my nums of mid value is less than target. Okay, basically my target is greater than, and my target value is less than nums of minus 1. It means we are in the right part of the below one. So in that case I have to just shift my low boundary to the right side, and if it is not fulfilling, it means I have to shift my right boundary to the left side. So in this way, like by using these two conditions, we can sure whether we are in the first part or second part. And if we are in the first part, so how we are applying this binary search, like we are ignoring which part. So for that we are checking our target, whether our target is present like middle, left part of the middle or the right part of the middle. If it is present in the left part of the middle, so we are ignoring all the right part, and if it is present right part of the middle, so we are ignoring the left part. In the same manner we are doing for the second part. So in this way we can do basically, and if it is not, we are not getting any element like a target, in that case I have to return minus 1 here directly. So let me run it. So it is giving some error. What error? Nums of mid. Okay, it is actually I use wrong name here. Okay, let me just, yeah, run it again. Yeah, so we can see here one of the test cases failing. Why? Let me see, my target is 2. Okay, so why it is failing, let me see again. we are defining my ij, my low and high, like my I and j is less than equal to my middle value we find first. Okay, that is also correct. And if my nums of m middle, like middle value is target, then we're returning a middle value directly here. If my num of 0 is less than, it means we are in the um, first part. In first part, then we are checking the range target, and target should be less than m. Then my high value is shifting, otherwise my low value is shifting. And if in the else condition, if we are checking my middle value is less than target, and like target is less than, okay, it can be equal to as well. That's why it is failing, because in this case we can see, for this case the target is 2, and target is 2 is like equal to this 2 last one, and if it is less than, it is checking. So in that case, it is, if it is equal, then that is ignoring. That's why it is, that test case is failing. Let me run it again. I hope it should run now. Yeah, let me submit it. Yeah, it ran. So it is taking 0 millisecond and beats 100% of user. So our previous solution as well, like I can show you here, like previous solution what we did. Like previous solution, we just find the pk element index, apply the left part and right part binary search, and in that way we solve. But that was taking 42.14 uh, MB, and it is taking 1.96 MB. That is actually memory perspective, but yeah, that is more optimum, because previous was taking three like binary search, now it is taking one binary search, and in one binary search we just like apply all the observation what we did in the previous question. So I hope you understood the solution and logic and intuition behind this, and you can also connect with the code whatever logic we explain, how we write. So if you like this video, please like it and share and subscribe my channel, so that if you share any video like in future, you can just go through and like enhance your problem solving skill. Yeah, thank you for watching my video.